Moving on, I want to start talking about really large data sets and how to use accelerators on the cloud platform. One of the big advantages of using cloud platform is you have access to different types of hardware. And here I'm going to show an example of how if I have terabytes of data or something, I can very easily set up a cluster. I'm going to choose again an environment for this to run in, a software environment. I'm going to choose small workers here, just since this is an example. And I am going to ask for a cluster of machines. And this will give me back a connector. And here I'm going to say, I want at least 5 machines, and I want it to adapt to 10. And so as we do the compute, it's going to ask for more machines as we have more things to compute. And so let me open some diagnostic windows so that we can see what's going to happen. Let me turn on the cluster map and also the progress bar. So there's the cluster map, and there's the progress bar. And now let's run a compute. This is using a Airline On-Time Performance dataset from the Bureau of Transportation. And if we look at this, I'm going to calculate how many flights we have per day in the last 20 years. And I'm going to plot the total number of flights every day for the last 20 years. And if you see this will start pulling in machines. Right now you see this purple dot is a scheduler, and in a few seconds you should see different machines popping up as they start up in the cloud. So now we have 2 machines, and it's going to start doing the computation and keep adding machines as it needs more compute. And then when it finishes running, it's going to shut the machines down. So this is a very efficient way of doing really big data without having server costs continuously. And so that we have the plot available now. And if we look at this is the last 20 years of flight data. And you can actually see when COVID happened and all the flights disappeared. And if you look at the whole plot, we're still not really back up to pre-COVID flights. And so this is sort of the power of being able to do interactive visualization on massive data sets. Now, the other way of accelerating things is using GPUs. And as you remember earlier, we picked up a server that's a GPU server. So I'm going to just turn on some plots so we can kind of see what's happening with the GPU. So right now we have a GPU, and it's using 0 memory, and it's not being utilized, which makes sense because we're not actually doing anything yet. And I have a little bit of code here that just takes PyTorch, takes the ResNet 50 model, and trains 2 epochs. Just to kind of show you that we now, in this platform, have access to GPUs, and we can also look at how well our model is doing and what resources it needs. So in a second, you should see the GPU starting to be used. And if you look at it, this model is using 7 GB of memory. And so in this particular case, using an A100 might not be the best option. And so the ability to access different GPU types very easily just by starting up a server and shutting it down is a key part of why such a platform like this can be very effective. In a couple of seconds, it'll finish running the second epoch, and you should see the GPU utilization go back down to 0. But it's still going to be holding the data in memory until we kill this notebook. Yep, and then it goes down. And if I restart this kernel, you should see the GPU memory also disappear. There we go.